Solve using matrices. 4x plus y equals 12, 3x plus 2y equals 2. Let's write the corresponding matrix, which will have 2 rows and 3 columns. We take the coefficients of the variables 4, 1, 3, 2, draw our vertical dotted line, and write the constants 12 and 2. Our goal is to get a 0 in this position. Looking ahead, what we can do here is multiply row 2 by 4. So row 2 multiplied by 4. Now that's going to give me a 12 in this position. And then what I'm going to be able to do is create a 12 here and subtract it to get a 0 there. So the first step, though, is row 2 multiplied by 4. Row 1 remains unchanged. 3 times 4 is 12, 2 times 4 is 8, and 2 times 4 is 8. Now what we're going to do is take row 2 and subtract 3 times row 1. That will go into the position of row 2, creating the 0 in the place where we want it. Now row 1 still remains the same, 4, 1, 12, unchanged. 12 minus 3 times 4 is 12 minus 12 for 0. 8 minus 3 times 1 is 8 minus 3 for 5. 8 minus 3 times 12 is 8 minus 36, and 8 minus 36 is negative 28. Well, now that we have a 0 in this position, we have the corresponding equations 4x plus y equals 12 and 5y equals negative 28. Well, that means we can solve for y. Y is equal to negative 28 over 5. Now we can take that value of y and substitute it into the first equation, 4x plus y equals 12, and solve for x. So 4x plus negative 28 fifths equals 12. Adding 28 fifths to both sides, 4x is equal to 12, which I'm going to write as 60 over 5 plus 28 over 5. So this is going to be equal to 88 over 5. But now we need to divide both sides by 4. When we do that, it'll be 88 divided by 4, which is 22 over 5. So our solution for this system of equations is the point 22 fifths, comma, negative 28 fifths.